Let's analyze this video of our projectile. The very first thing we did was find the time, which was 2.88 seconds. Then, using the VF equation, we found the value of VI, which was 14.11 meters per second. After that, we were able to find the Vx value, which was 9.313 meters per second. After using the Pythagorean theorem to find out what the hypotenuse is, which is also the total velocity, you're able to use inverse tangent to find the value of theta, which is 56.57 degrees. So when all is said and done, our triangle should look a little bit like this. An angle of 56.57 degrees, a Vy of 14.11, a Vx of 9.313, and then a total velocity vector of 16.91 meters per second. Another important piece of this is that the max height is 10.16 meters, which was found by squaring the vertical velocity vector and dividing it by gravity times 2. The vertical analysis for position versus time is a parabolic shape because it's symmetric motion and it's ground to ground. So it reaches a max height, stops, and falls to the ground again. The velocity graph, it has a positive initial velocity, but that velocity hits 0 at the top of the motion, and then it begins to accelerate downwards, which can be seen when it goes into the bottom portion of the graph. The horizontal velocity during a projectile motion remains the same the entire time. It doesn't change. So that's why you can see in the position versus time graph that it stays constant the entire time, and it moves at a steady rate over the course of time. And then for the velocity graph, it remains the same because obviously, the velocity is constant, so it remains at that 9.313 meters per second the entire time and does not change, assuming there's no forces acting upon it, such as air resistance. And then finally, to touch on velocity vectors a little bit, you can see, as I stated in the last section, that the horizontal velocity vector remains the same size the entire course of the motion. This is because there's no forces acting upon it, assuming there's no air resistance, and gravity. So the one that's affected by gravity is the vertical velocity vector. So you can see as the projectile moves up towards its peak, the vertical velocity vector becomes smaller and smaller because gravity is acting upon it. So when it hits 0, it begins to travel back towards the ground and gain velocity as it goes towards the ground, which is why the arrow becomes bigger. And then because the vertical vector is changing due to gravity, the total velocity vector can be seen changing throughout the motion as it goes up and then down again. Alright, thanks so much for watching my video on analyzing my projectile motion. I hope you're having a great day, and I really hope you enjoy my project. Peace.